absolutely obligatory. I have to do it because they give me the day off if I do. Corporate slide. I work for a company called NCC Secure Test. We're a pen testing company going for the last 10 years in that field. Largest security teams in the UK. Personally, I've been in IT and IT security now for about 14, 15 years. I'm a pen tester, ethical hacker, and I'm also the chapter leader for OWASP Scotland. I actually have an initial question. Who's heard of OWASP? Okay, that's not too bad. OWASP is the Open Web Application Security Project. They have a whole load of free material around the idea of information security, around the idea of web application security specifically. And they've got some very good stuff like coding guides and testing guides and security development guides and various things which are quite handy to look at. They also have a nice chapter organization, so if you're interested in that sort of thing, you can look on the website and find out if there's a chapter near you. Okay, what pen testing isn't? Halle Berry's never helped me on a pen test, and I don't get 6 screens. It's unfair, but true. So what is it? What is penetration testing? That's what I'm going to start off with, is a little bit around what this is, a little bit around why you would use Ruby, and then hopefully some demos which I'm really hoping are going to work. Because hacking stuff live is never usually a good idea, but hey. Okay, so review security just about anything. Essentially what we get asked to do is we get asked by customers to look at the security of their systems, and that can be of a wide variety of systems. Web apps is the most common. So I'd say about 60–70% of my time is spent testing web apps, so breaking into them, finding injection flaws, authentication flaws, authorization flaws, input validation, all that sort of stuff. Server operating systems. That's the old classic. The way people used to do it was you break into your Windows server. 10 years ago, that was pretty much a lot of what it was. Less so now. Databases. Yeah, well, bad guys want to steal data. Customers realize that. They store everything in nice, secure databases. We'll have a look at that in a little bit. Custom application code, so it could be looking at reviewing code. Wireless networks, it gets a lot of press. It's less so now, but yeah. Cache machines. We get asked to review cache. It's amazing. Cache machines are built on Windows these days, which, for better or worse, they are. Yeah, and anything. Essentially, we test assumptions about security. So when people are designing and developing systems, they make assumptions about security. They assume that certain things they do will be secure, they'll protect them from a certain class of attack. And what the people get us in to do is to say, okay, prove or disprove that and work out how you're going to do it. So why Ruby? So, okay, so now I'm doing a test, I'm doing a pen tester. Why would I use Ruby for this? Well, it fits in really well with pen testing. First part, short time frames. A standard pen test will be between, say, 3 days and maybe a week, 2 weeks, absolute tops. So if you need to write some code during that test, you cannot be mucking about. You have to write it very quickly, get it working, and do whatever it is you need it to do. So speed works well with Ruby. Varied requirements. Yeah, so we could be trying to test anything. So having a language that will easily integrate with a wide variety of platforms is pretty much a requirement. Yeah, and cross-platform support. Hacking, yeah, most of the tools running on something like Nokia 900 runs Linux, therefore runs Ruby, therefore runs most of the hacking tools. So the way I wanted to do this was just kind of go through some of the challenges we face in testing and also some of the ways in which we would use Ruby. There's a variety of different ways in which we'd use Ruby as part of that. So a number of phases. Scanning is the first phase. So the very first thing you need to do in a test is try and find out what you've got to attack. So essentially we're attacking targets. So how do we do that? Well, you scan around looking for things. We'll cover that. Exploitation, that's the fun stuff. And that's where we actually break into things. Post-exploitation, once you've broken into something, typically you are, as part of the test or as part of an attack, you're looking for information. So how easily can I get information out of a system? What can I do once I've got that initial exploit completed? And unfortunately, people make me write reports afterwards. This is really boring, but the client doesn't pay you unless you write a report. So let's walk through some of the stages and see where Ruby can help. Start off with scanning. So the very first thing, if I'm given a network, so if you're given a network, you're told, right, you're pen testing this network. The very first thing you've got to do is try and establish what there is to attack. Okay, so the standard way of doing that is using port scanning. So essentially looking around all the hosts that are running, looking at what services they've got running on them, and then enumerating those and working out how can I attack each one of those systems. The first thing to do is find out what I've got. So we would typically say we're given 2 class C, so several hundred IP addresses and told go and find out what's there. So it's a requirement to find out what's there fairly quickly so you can start doing the actual breaking in. So what services are available? De facto tool of choice, Nmap. Anyone used Nmap? Yeah. Okay. Lots of people use Nmap. Great. So everyone knows Nmap is basically constantly developing. I mean, the guys have put so much more stuff into that than was even there like a year ago, 2 years ago. It's a very good network mapper. It's very, very fast, which is kind of the critical point. Because if you're scanning 65,000 ports on 500 hosts, you can't have it take very long per port. Otherwise, you're going to be there for a while. Quickly assess what the attack surface is. So what are we actually going to be attacking? They also added in a whole lot of additional scripts to use Lua for this. So essentially you can write Lua scripts which plug into Nmap and do additional things. So a guy's written a whole lot of stuff for Windows. So like enumerating Windows domains, enumeration, all that sort of stuff actually built into Nmap. So you get, it doesn't just do port scanning anymore. Yeah, okay, so it gives us XML output. Great. So as we all know, XML is a bit verbose. So that's the typical sort of stuff it comes out with. Now, what I've done here is I've got a sample of a couple of hosts. But even then, as you can see, it's a bit overly wordy. And you don't really want to be trying to look through all that, trying to find what information you're looking for. So one way of doing that, I'll go back to the slide briefly. Ruby Nmap. So there's a Ruby Nmap library, which essentially just is a gem, you can install it, and it'll allow you to parse through Nmap quickly and find out what it is that's actually interesting there. Find out what you actually need to get to move on, which is kind of important. So that's really quick code. As you can see, it's really very straightforward. We just get it tells what hosts are up, and for each host that's up, get it tells what TCP and UDP ports are running. So pretty straightforward. So where am I? And here am I. Yeah. So from that big, large, huge XML file, it's really straightforward to come up with something which just brings us down to the bare minimum, what we actually need to know to get on with the test. So what we've got is we've got 3 hosts there. .2 has got some ports open. The kind of interesting stuff there, that's probably going to be a Unix box. So it's running 22 and 1522 anyone? 1521 anyone? Oracle, which is Oracle TNS. So it's an Oracle box, in all likelihood. 3 is interesting because it's got absolutely nothing open. So that host is firewalled. You're not going to get anywhere with a direct network attack because there's nothing to attack. And number 4 kind of looks like a Windows web server. You know, it's got the Windows ports 135, 139, 445. That's Surefire Windows box or something running Samba. 1433 SQL Server, 80 web server. So between that lot, you can fairly easily come to the conclusion that what I'm here to attack is I'm here to attack a Windows server, something that's firewalled, and a Unix box running Oracle. 3 very different types of attack. Okay, and we import results from that into Metasploit. Metasploit, how many people have heard of and or used Metasploit? Okay, so some. So Metasploit it's probably the largest Ruby-based pen testing framework out there. Excluding external dependencies, it's about 250,000 lines of code, Ruby code. So it's a relatively large project, and it's very actively developed. They come up with new stuff pretty much every other day. It covers a lot of ground. Essentially, what Metasploit does for us, or what the main thing it does for us, is it speeds things up. So I'm doing a test in 3 days. I could write stuff from scratch, but no one's going to pay me for 3 weeks to sit there and write that stuff. I need to have something I can run quickly. So what you want is a framework that will do that for you. And essentially, that's what Metasploit is. So it helps with exploit development. When guys are doing, so you'll see, did anyone catch the coverage of CanSec West? There's a conference on at the moment. There's a security conference called CanSec West where they have a competition called Poon to Own. And basically the idea is if you get an exploit, a 0-day exploit, and run it on a platform, you get the kit that it was running on. And they put up some Windows laptops, some MacBooks, iPhone, and basically every single one of them got owned yesterday. So the iPhone, they managed to get all the contact and email information out of the iPhone just by going to a website. They got full control of the MacBook over Safari just by going to a website. Same with Firefox on Windows, same with IE8 on Windows did as well. So basically, when you're doing that sort of stuff, these guys had more time because they knew the competition was coming. If you're doing it yourself, you want to be doing it quickly because you don't have a lot of time on a test. You don't get, they had a year to prepare. Network testing. So this is what we're talking about here, coming in over the network, trying to assess what hosts are there. Web app testing does some stuff for that as well, not so much. And a whole load of other stuff, which I might cover more of depending on how I get on with time. Okay, and far more than just DB autopoon. A lot of people get hung up on Metasploit. It has this function called DB autopoon, where essentially you just run Nmap, import it, and then tell Metasploit to try every single module it knows of that hits a certain port on every host that it found. Don't ever do that in a real test because you will break stuff. It will pretty much guaranteed to break something. You'll knock a service over. So not all the exploits are very reliable. It got a lot of press for that. It is a cool feature, but I would never use it. You never use it in real life. Okay, yeah, I have to do this one as well. Never, ever, 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 ever run tools like this on systems you don't own or are not responsible for. If you do, bad things might happen. Very bad things, depending on whose system it is you're running it on. Really, don't do that. Okay, so rapid deployment of traditional vulnerabilities. So buffer overflows, stack overflows, the kind of things that were used for the worms around the end of around the turn of the century. There's a lot of Microsoft worms that got them into huge amounts of press. We don't see those so much anymore, but to be honest with you, depending on the type of pen test you're doing, you might well see things like that. So Windows boxes that are 4 or 5 years out of date with patches. So at that point, network testing is actually pretty cool. Yeah, networks where patching isn't updated is a great option for getting in easily. So MSA 08067 was one of Microsoft's Samba. I think it was a Stack Overflow. But basically, it's a very reliable vulnerability. So I say very reliable before I do the demo. But we'll see whether that's actually the case or not. OK, so thank you. Didn't need that. So here we have Metasploit up and running. As you can see, there's 500 plus exploits. Auxiliaries and payloads. I'll talk a bit more about some of the other types as well. So, exploit, Windows, Samba. Oops. Okay. What we can do with Metasploit is, the really cool thing it does, which is really useful, is it has a whole load of different payloads. So depending on what you want to do to the machine that you compromise, it can do a whole lot of stuff for you. What we're going to do at the moment is we're going to use one thing called Meterpreter, which I'll talk a little bit more later, but it is a very useful thing. Show options. So here we're targeting our Windows server, which is the one we found earlier on. And we're targeting 445, which we know is open because it was on our port scan. So there's our basics of our attack. And then what we're doing here is we're saying, if you manage to compromise this, so if you actually manage to run the buffer over successfully, bind as a port on the box, 4444, doesn't really matter, whatever you like, and then run Meterpreter, which is the payload. And in theory, if I just type exploit, it'll go away, do its stuff, set the stage. Boom, my server. Woohoo. So I'm now NT Authority system on that box. My box. I can do anything I like to that box at that point. You know, we'll come back to that. I want to do some more post-exploitation stuff. But that, so I'll background that for the moment. And then we can actually see, yeah, so we've got our sessions list there. We need to come back to that. So that's, yeah, okay, great. Woo, really easy. Hacking, who said it was hard? All you need to do is run that. And I'd love to say I'd never seen that work on a live company network, but I would be lying, because I have. I've seen ones older than that work quite successfully. People, tends to be you get servers in, if you're ever in a large company, you'll find some server away in the corner that they bought off someone with a service running on it that just works. No one touches it, guarantee it's not been patched. And things like that will work. Disappointing, but true. So, okay, so that's great. So we've got a server, but that's kind of easy. Client-side attacks are, these days, client-side attacks are where it's at. You know, if that's what I was saying about Pwn to Own, every single one of those exploits that they had someone develop and they got used were client exploits. It's all about attacking individual users because you want to try and use them for spamming, or you want to try and get their banking credentials off them, or you want a variety of other stuff. And what attackers worked out is the easiest way to do that is not to attack servers, because people worked out about patching, at least on the internet. People worked out patching. That's a lot better than it used to be. But patching clients, patching individual workstations, Windows patches, yes, probably. Adobe, probably not. Flash, probably not. Java runtime, probably not. All these things don't tend to get patched. So it's a really good way to attack people. Combined with a bit of social engineering, please click this link. You can get great results. Again, strangely enough, Metasploit and Ruby can help us do this. What Metasploit is, as they actually again realized you don't want to be doing this stuff manually. So what they've done is essentially allow you to create malicious payloads. So they've got various exploits in there that allow you to create a malicious PDF, a malicious exe file, a malicious anything you like. And you can also embed the payload into an existing exe or an existing PDF. So get a PDF you know someone wants to see, embed the exploit into it, they open it, exploit runs. Thank you very much. So. And yeah, antivirus. Lots of people say, well, yeah, but I run antivirus, so it's all good, isn't it? No, not really. But again, attackers are kind of leading the way on this, and the pen testing stuff is there. It's probably not quite as advanced. Basically, there are sites like VirusTotal out there which allow you to run your binary, your malicious payload against all the common virus engines. And what bad guys will do is they'll just keep tweaking it until it shows past all of them. So they know for a stone cold fact on the day they release, they're going to be okay. They'll get a guaranteed compromise. As time goes by, obviously the antivirus vendors will catch up. They'll see the thing being exploited in the live, and they'll introduce a new signature to catch that. But pretty much that's how they do. That's how you get past 8 and most AV. And Metasploit can do that as well. I won't actually do encoding and antivirus because that's likely to be a bit more tricky. But so. Format. Okay, so there's a bug in Adobe Acrobat Reader in libtiff. This was revealed not all that long ago, actually. Yeah, this works up to Adobe 8.2 and 9.3. So that's, I think, they've only just released the patch for this. That's the other thing is exploit development tends to be a lot faster than it used to be. This came out, the bug came out, and this was into Metasploit within about 3 days. So it was a pretty short time frame. And what we can do here is this. If we look at show options, fairly handy. Metasploit always gives you the show options. It's essentially you can see what it is you want to do. And here it just says, right, we're going to generate a file name. So we'll call our file name evil PDF. So that no one's in any illusions about what it's going to do. And then we need to tell it the payload again. Now, this time we can't do what we did last time. So remember last time, what I did was I said bind a port, so create a new port, bind a service there so I can essentially connect into it. That isn't going to work here because that machine had a firewall. The client's got a firewall, I can't do that. Not a problem. Not a problem. All we do is we say, Windows, oh, helps if I tell it it's payload I'm trying to say. Reverse TCP. So basically, yeah, get it connect back to me. Come back, just come. So this basically means that the machine can be firewalled as much as it likes. As long as it can make a path back to my machine, it's all good. So show options. We need to tell it what my local host is. So set lhost. So we need to tell it where to connect back to. 168.64.1, which is me. And then theory, right? So, and then I just run exploit. Now, no session was created. That's fine because our unsuspecting user hasn't yet opened the payload. So, what we need to do is we need to get Metasploit ready for when that happens. And basically, this is just a thing this is just a piece of code which will receive the connection back. So when someone connects into it, it says, "Oh, you're connecting with this type of payload. On you go." So we just tell it the same thing we did last time. So Windows interpreter, reverse TCP. Show options. Did it retain that? No. Okay. And then I'll now sit there and it will wait for a connection to come back to it. So now we need to get our PDF, our evil PDF, we need to get our user to actually run it. So, where am I? Yay. So strangely enough, Ruby can help me here too. So I need a web server basically, because I'm going to try and get my user to go to a web server. I'm going to try and get them to click a link. I could do that anything, I could say it's scantily clad pictures of some lady or whatever is today's flavor of the month to get someone to click the link. So I need to have a web server. Of course, with Ruby, that's absolutely easy. So I've just essentially knocked this code up really quickly. As you can see, all it does, it just uses rack. And then says, okay, read in my PDF file, have a port running, and then if someone goes to evil PDF, give them the content. Okay, that's fine. And we go back to our shell. And we just say, right, PDF server. Okay. So, oops. Here we are in our client, totally unsuspecting. He's received a link that he thinks is really interesting. So he opens his browser, and he goes to his link. Your totally safe PDF here. So he clicks the link, because he's that kind of guy. And it, well, no, nothing really happened, did it? Where's my display? Oh, it did. Oh, it's my machine. Great, excellent. Different session. Oops. There's my Windows XP SP2 box. So I now own that machine too. Great, 2 machines, really quick. And I said that kind of attack, albeit probably not using Metasploit because they kind of do this stuff on a much larger scale, is pretty much what bad guys will do. There's actually a new payload, it's not really finalized yet, they're working on, which wouldn't even allow, doesn't even require a listening port on the attacker's machine either. It runs everything over DNS. So essentially it uses DNS as a transport protocol and just makes queries to it. All you need to do is own a domain name and it says data at domain name and it just chucks all the data through that pipe. And it's, so yeah, no ports needed at all. I'd love to see anyone detect that in the wild. So, great stuff. We now have 2 machines to play with. I'll come back to them. Databases, like I said, databases are fundamentally, for a lot of attackers, where it's at. If I can own the database, do I really care about anything else? If I can get all the credit card numbers that are doubtless in there, which is what if I was a bad guy, that's actually what I'm looking for. Okay, another area to test. So yeah, I want to get access to data. I'm an attacker, I'm a bad guy, and pen testers, we're essentially simulating bad guys. We're pretend bad guys. Okay, strange enough, Metasploit can help us here too. I didn't see that coming. Okay, so let's background that one. Oops. This comes on to, does anyone use Oracle much in the Oracle databases? So Oracle databases tend to get touted as being this incredibly secure enterprise. Yeah, okay, I'm on video. It's still true. They get touted as being incredibly secure in enterprise, and if you take older versions and take them out of the box, they were hideously insecure, which, as I shall show. So they've got some modules which essentially are just designed for various things. Now this kind of set. So if I set the R host to be our database server, which is the one we found earlier on, and then I say run. So essentially what this is going to do is it's going to try and brute force access to the Oracle database, looking at several common usernames and passwords. And again, I'd love to say I've never seen these, but it wouldn't be true. It is possible that you will find systems on a network where people haven't disabled the default accounts, so they take the default install of Oracle, which puts a whole load of, or used to, it doesn't do so much now, but it used to put a whole load of default schemas and a whole load of default users in there, and you can just find them. And so essentially what this will do is it'll go away, and it'll run through a list of, I think it's a couple of hundred, and there's a guy called Pete Finnegan who has this list on his website, and it's great, because it essentially has got all the ones, they update it when new versions come out. And in theory, this takes a little bit of time because it has to go through. Oh, there we go. Great, excellent. Scott Tiger. So Scott Tiger is open. I have seen this, so it's not totally without the bounds of possibility. So essentially what this has done is it's found me a default username and password. Excellent. So I now have some level of access to that database. But if I go to here and I go plus, so I now use my newfound credentials that I've got, and I log into the database server. Okay, so I can get on here, that's great. The first thing I want to do is, how much power have I got here? What can I do? Okay, I can do a bit. These are the roles, these are Oracle roles which that user has been granted. And basically those roles will let me do some stuff, but they don't give me what I want. There's a magic word missing from this list, and that's DBA. I need to see DBA, because if once I'm DBA, it's all over, it's my database server, I can do anything I like to it. So I want to see DBA in there. I wonder if I can make that happen. Auxiliary. So it turns out that, unfortunately, Oracle now, which one was I going to use? Just a sec. CDCID publish, okay. CDC. Okay. Unfortunately, Oracle have left a number, or had, and still do to an extent, a number of SQL injection vulnerabilities in their database store procedures. So essentially, there's a whole lot of functions and modules there which get shipped with the database. Those have got SQL injection issues in them, which means you can inject your own data into them. And the weird part about, or for me, the weird part about the way it works, is the way Oracle works is if a user defines a process, defines a piece of code, and then that code is executed by someone else, it's run in the context of the person who defined it, not the person who's running it. So if sys defined a piece of code, and I run it as me, and it's SQL injectable, I can be sys. This isn't really very good from a security standpoint. So I just say set database server. Okay, and if you look at the options there, you can see essentially it's doing what I want it to. So what we're saying is log in as Scott and Tiger, log into the database server to set, and the SQL I want you to do is grant DBA to Scott, and that's make me a DBA. Yeah. Apart from some errors, it looked like it was cool. So what happens if I, oh, SQL Plus doesn't let you do that. Hey, DBA. Great, so I'm now DBA, my database server. I can do anything I like to that database server, including wiping the audit logs and various other interesting pieces. But that's now my database server. And essentially, the role of Metasploit in all this is each one of these things like database exploits were, you know, this and still are, you see them elsewhere, but Metasploit provides a nice framework, and it does a lot of the stuff for you. So it does all the logging for you, and it does the session handling for you, and it does Meterpreter, which is what we're going to, how am I doing for time? Not too bad, actually. Cool. Okay, post-exploitation. So now, great. I've got my boxes, I've got my shells, but if I'm a pen tester, I need to try and grab information that's on there, and I also need to try and make more of what I've got. So maybe I've got some little server off in the corner, and what I really want is the domain controller. Because if I get the domain controller, I can dump all the user's passwords, I can crack them, and I say, hey, look at all your weak, insecure passwords, which makes good writing in the report. So what to do with it? So there's a thing called Meterpreter. Now this essentially is it's a Windows-only thing at the moment, although there is meant to be a Mac OS X version coming out. Essentially, Meterpreter is a payload, and it allows you to do a whole lot of things once you've. So usually when you compromise a box, you just get an ordinary shell. So you get like command.exe, which isn't very useful. Yeah, advanced payload, and very friendly for Ruby users, which is kind of interesting. So if I go back here, and I go back, and I go sessions. And sessions. These are the sessions I left behind before. So I do minus I1. So here's me back on my Windows box. I can do a variety of things here. So I can say, okay, I need to say use proof first. Use proof. That's already loaded. Cool. Hash dump. Hey. That's the hashes for all the users. Those are the password hashes for all the users on the box. So at this point, if I want to, I can take those away and crack them. So if I want to, you know, so I've got access now, but I'd like to come back, and it'd be helpful if I had the password, because then I wouldn't have to break into the box again. You just need to take those away and break them. And definitely the administrator user will be breakable, and a couple of other ones will. Some of those accounts might not work, but quite handy anyway. Maybe I also need some evidence for my report, because I need to put some screenshots in. So yeah, there we go. That's a screenshot of the box as it's running at the moment. Okay, it's kind of got the Windows thing up, but we could change that. Hold on, let's. Other box. Back to my Windows server. VMs. So here I am. Okay. Leave that there. Yeah, so yeah, I can grab that, no problem. So I get screenshots. That'll make my report look nice, which is good. What else can I do? Well, hopefully it'll tell me. So I can timestamp. Timestamp essentially is you don't really want the forensics guys to work out where you've been. So you want to change all the time attributes of every file you've touched and or modified. So this will just do that. Essentially, you can go through and change that. Get system. If you get onto a system with essentially when you compromise a box, when you get you compromise a service, what will happen is you'll get on as the user who runs that service. Now, obviously, you want to be root. You don't want to be, you know, an ordinary user. So you just get system. key scanning. So if you want to, so this is a talk about making things faster. A lot of this stuff is possible, but it's really much easier to just do it this way. So I can do key logging. So if I want to key log it to get some evidence to say, okay, this is what you were typing on a given day, that's good evidence of the fact that I've compromised your server. And yeah, and there's a whole lot of stuff. And the other thing that's kind of cool, incognito. There's a thing called incognito, which is an extension. Load incognito? He said finding, I don't know where I put it. Yeah, use incognito should work. Oh, help. Oh, help if I could spell, huh? Hey. And what that does is that adds some additional commands. So essentially what this does is, it turns out that there's a guy called Luke Jennings who did some research, and he worked out that Windows leaves behind tokens. So if I log into a Windows box, a Windows server, and then I log out, the token will stay there in certain cases until that box is rebooted. If someone gets onto the box, they can then use those tokens, so they can be me as much as they like, which is really quite handy if you're a pen tester. So list tokens. So yeah, so that user there, the VM demo administrator, that's who I'm currently logged in as. So if the attacker wants to be that person, they can just say delegate token and say, I want to be that user while I do this. And also from an auditing point of view, it'll look like whoever user was. And they don't have to give their password away. You don't need to know their password. It just nicks the token, which makes things nice and easy. It kind of, yes. It seems to be, it's an inherent limitation in the way you can tell later versions of Windows not to do it. So you say, do not leave tokens behind. This token is not available for delegation. Don't allow this to happen. But realistically speaking, with interactive login, it will leave it behind. I shall. I didn't need to do that. Okay, and the other thing, which is really quite cool, is, I have MERB. You get an ERB shell. So essentially, you can get ERB from within Meterpreter. So I can do things like, it'll just return a hash. And it essentially, you can do, so I do client.mymethods. So yeah, so you can do my methods, you can do all the ERB stuff, and you can get, you can use that essentially to manipulate the client to either get information out of it. This is really handy if you need to automate. So say I compromise 100 boxes, not one. I want to do this automatically. I don't want to log into 100 boxes, get the information and walk away. I just want to do it one time. And you can do that because you can essentially just do it the same way. Oh yeah, there's a really kind of, what can I just paste it in? So essentially, is a really obvious example. So if I want to know what interfaces, so I want to know what network interfaces are on this box, in case it's got more than one, like it's in a demilitarized zone and I want to go onwards into the internal network. So yeah, it tells me what interfaces are running and what the IP addresses of those interfaces are. And that essentially is a reasonably straightforward, very handy way of doing it. And what they've done is it's underlying C code, but they've wrapped it in a kind of Ruby-style API, which makes it kind of easy to use. So those are and essentially dealt with any Meterpreter shell. So that essentially post-exploitation, very handy, very nice for Rubyists. You can almost use this. They've actually got a payload for logging in with real credentials called psexec. It just essentially logs in and allows you to do commands. You can use it for system administration. Get this thing, log into all the boxes, have it do something on each box. Easy to automate. So yeah, people make us write reports at the end of it. Yuck. Yeah. So there's a thing called Dradis. Has anyone heard of Dradis? Ooh, stunned silence. Dradis is it's a Rails app, but it's really quite handy. Hold on, let me. Okay. Where are you listing? Oh, what sends you? Oh. Help if I told it. Very security conscious. Essentially what this does is it's just a nice way of managing all your data. So if I want to test and you've got a lot of these XML files and various other things getting flung up, you don't want to be trying to do all the text files. You want a nice place to put it all together. And the good thing about this is you can do you can import. So I can import mmap files into this, and I can report my Nessus files. There's a tool called Burp. You can import. So you can import a variety of tools. This makes reporting much more friendly. Yeah. So that was Metasploit, and I kind of focused on that because it was a good place to get a lot of information about Ruby and pen testing into one place. It's by no manner of means the only project that people who are doing pen testing have developed. Pen testers like monkey patches. Pen testers like, because essentially we'll be dealing with strings a lot of time, so what we want to do is extend the string class to allow us to do things that pen testers, so things like base64 encoding, URL encoding. If I'm testing a web app, I need to be able to URL encode things easily, so it's handy to have that added in. And so there's projects like Ruby, Black Bag, and Ronin, which allow you to do that. Yeah. So yeah, things like calculating entropy. So when you're doing web apps, you'll be looking at session tokens, and the thing you want to work out is, are these truly random session tokens, or are they actually predictable, and I might be able to predict what they are and get unauthorized access. So things like calculating entropy are very handy, and MD5 hashing. Yeah, pulling printable strings out of binary. It's amazing what you find by getting things like management consoles, downloading the Java applet they use to run, and then just either decompiling it or running strings on it, and you get all sorts of really interesting information. Yeah, and be able to find out things like SQL injection again. So where to get more information? There's loads of places to get more information on this stuff. Metasploit didn't used to have a great deal of documentation, but that's a lot better now. Also, there's an online training course which is free, which goes through pretty much all of this kind of stuff. It also goes into some more detail. That's offensive security, Metasploit Unleashed. And there's some cool blogs as well. Dark Operator. This guy's written loads of Meterpreter scripts to add on. So he's written one which, if you ever want to kind of annoy your friends, he's written a script that once you've got your Meterpreter running, you can rickroll them. So not only can you rickroll them, but it'll disable the keyboard and mouse and rickroll them at the same time. So maybe not the most practical thing for a real test, but could be useful. And yeah, pen testing in general, if that's something which is of interest. OWASP have got the testing guide. There's a big testing guide, like 200-300-page testing guide, free to download, totally free to use. And ISOCOM have another one. There are other ones, but these are two main ones. OpenScore Security Testing Methodology Manual. Questions? Anybody questions? I haven't actually run across, I think we'll see more of them coming on. But I haven't had cause to yet. In the work I've done looking at Rails security, because the framework does a lot for you, there's less to attack. I always find that the main thing, the places you always, web apps you always get into is where the individual developer is forced to make all the security decisions himself on the day. Because then, especially in big companies, you're talking about a team of guys, one guy doesn't know about injection, he writes a module, he writes a page, and instantly you're in trouble. Whereas the framework deals with that for you. So you've got ORM, you've got whatever, you've got the HTML encoding stuff that they're doing in the latest versions. At that point, it becomes less likely that you're going to find something. It's, you get applications where it's just bad, they just didn't understand security and you're going to break in all sorts of ways. But most of what you see is applications where they knew what it was, but there's a bit that they missed. There's an element. And so the more you can abstract away into the framework, the better. Any else? Is that us? How am I doing for time? Oh, not too bad. Cool. Well, oh, yeah, sure. Oh, hang on, I think we've got a mic coming.
What would be your first or your sort of number one recommendation for securing applications, or your sort of main gripe?
For web app security, it's input validation. Input validation every single time. Because if you look at how people have actually compromised vulnerability, you look at some of the big credit card compromises where they've got X million credit cards, they're pretty much all SQL injection. And the reason for that is that SQL injection is a great vulnerability because it can get you not only access to the database, but depending on the database, can get you all the way down to the operating system and onwards. And I've seen that done. Essentially, if you have a situation where you know what class of data you want to take, if you're taking name, you know what set of characters you want to take, only take those characters. It's the easiest way to stop the problem because you can't know every meta character in every language, in every place that data is going to pop up somewhere else that might have significance and might cause a problem. So the easiest way, if it's possible for the application, is just to strip everything when you get it. And that way you've got less of a problem. Although I also recommend HTML encoding for anything you're chucking out to the browser, because the problem with that is if your data comes in from somewhere you weren't expecting it to. So for example, I always thought that browser identification strings, so in your user agent, I always thought if you put a cross-site scripting string in there, you get a whole lot of places where people use that user agent and bet you any money they don't encode it all, because they'd think, how would someone change it? Well, it's trivial. You can get a Firefox plugin that lets you change your user agent. You change it anything you want. So input validation would be my number one. For systems, default passwords. The number of times I've found default passwords, it's ridiculous. So if you get a piece of hardware, an operating system, an appliance, anything like that, read the manual, find out what the default passwords are, and change them. Cool, anyone else? Or oh, yep, one at the back.
You successfully scared me with your tools. I want to know if you were running these tools against any production web servers today in the net. Do you all do that often? And what are the top security measures you would take initially, at least at the starting level, to protect a web service against this?
So, yeah, we do a lot of external stuff. I mean, most of the testing we do would be against external internet-facing kit. To be honest with you, infrastructure stuff tends not to be so much of a problem because you'll almost always have a firewall, which almost always, I mean, that's an absolute no-brainer. Don't allow any ports you don't need to. Don't allow remote desktop. If you want to do something like have remote desktop listening, lock down what IP addresses you can come from. It's an amazingly easy thing to do. If you're only going to come from certain ranges like your company, so you've got a hosting site and you want to administer the box, lock down the IP addresses. That way no one else can see it. That makes things much easier. So anything you can't get to is something I can't attack. So the less I can attack, the harder it's going to be for me to get anywhere, basically. Web servers, keep them patched. Frameworks, keep them patched. Patching is, because the thing is, vendors, when they tend to bring out a new version, they'll tell you what they've fixed. And it tends to be security problems. So PHP is a good example. PHP fixes security problems pretty much every release. You can go and look at the release notes and find out what they fixed, and then go and see if there's an exploit for it. And that's that. Even I'm on a test, and it's not a long test. That's something that's quite easy to do. Go and look at what So they're running PHP version whatever. And the other thing, which it kind of comes over as security by obscurity, but I think it's well worth it, is hide version numbers where you can. Don't give the attacker information unless you have to. So there's no reason to be telling him what version of Apache you're running. There's no reason to be telling him what version of PHP you're running. That just gives him information he can then more easily attack you with. And the other thing is, there are ways to scan around the internet. There's a search engine called Shodan, which looks at headers. So essentially it captures browser web server banners and SSH logins and telnet logins. So I can search that like Google. And I can go, give me all the people who are running this known vulnerable version that I got an exploit for. And it'll do it. And then at that point, I can just go automate that process and say, thank you very much. So if you hide that information and don't give the attacker that information in the first place, it just makes it that much harder. It means you'll be below, if someone targets you directly, you might be in trouble. But a lot of the time out there, it's people just randomly scanning the internet looking for hosts to compromise. And that's a good place to start. Anyone else, or are we good? Cool, thanks very much.